When water meets fire, Africa sits on one of the most active geological regions on Earth, the East African Rift System. This immense crack across the continent is slowly tearing land apart, allowing magma to rise closer to the surface. When groundwater interacts with volcanic gases or hot magma chambers below, chemical reactions occur that radically transform the water above. A normal freshwater lake can become a caustic, boiling, acidic cauldron. Many of the most dangerous acid lakes sit directly atop volcanic vents. These vents release gases such as carbon dioxide, sulfur dioxide, and hydrogen sulfide. When these gases dissolve into lake water, they form powerful acids. The process is similar to adding carbonation to soda, but 1,000 times more intense. Instead of forming harmless carbonic acid, lakes near volcanoes can produce sulfuric acid, hydrochloric acid, or mixtures so corrosive they can strip paint, dissolve metal, and prevent all but the hardiest microbes from surviving. Africa's geological forces continuously feed these lakes with fresh acidic gases, meaning they never stabilize into harmless water. Instead, they remain in a constant state of transformation, bubbling, steaming, and churning with chemical energy. Lake Nyos. One of Africa's most infamous lakes is not acidic in the typical sense, but its story is essential in understanding how chemistry can transform a lake into a deadly force. Lake Nyos in Cameroon is a volcanic crater lake that silently accumulated vast amounts of carbon dioxide in its deep, still waters. Because the lake sits in a calm basin, the gas dissolved into the water and remained trapped there for decades, forming an invisible reservoir of potential disaster. In 1986, that disaster arrived. A rare event known as a limnic eruption triggered a massive release of carbon dioxide that burst from the lake like a shaken soda bottle. A thick cloud of CO2 rolled through nearby valleys, displacing oxygen and silently suffocating more than 1,700 people and thousands of livestock. The lake itself turned a rusty brown as gas churned from its depths to the surface. The event remains one of the most shocking natural disasters in modern history. And though Lake Nyos is not acidic like some others, its connection to volcanic gas makes it part of Africa's family of extreme lakes. It showed the world that a lake influenced by volcanic forces is not just a chemical curiosity. It can become a deadly phenomenon capable of reshaping human understanding of natural hazards. Lake Kivu, straddling the border of Rwanda and the Democratic Republic of Congo, lies Lake Kivu, a giant, serene body of water with an ominous secret. Beneath its calm surface sits one of the largest concentrations of dissolved gases anywhere on the planet. Methane and carbon dioxide fill its deep layers, trapped by pressure and density differences in the water. Lake Kivu is so large that if it were to experience a limnic eruption like Lake Nyos, the result could be catastrophic on an unprecedented scale. Millions of people live along its shores. The lake's methane stores represent both danger and opportunity. Some nations have begun extracting the methane to generate electricity, reducing pressure in the gas-rich layers and providing renewable energy at the same time. But the geological risks remain. Volcanic activity from nearby Mount Nyiragongo constantly threatens to destabilize the stratified layers that hold the gas in place. Unlike Lake Nyos, Lake Kivu is so massive that a full release would dwarf any previous event in scale. It stands as one of the most silently dangerous lakes in the world, where the boundary between an energy resource and a natural weapon lies in delicate chemical balance. Lake Natron. Lake Natron in northern Tanzania might be the most visually stunning and chemically extreme lake on Earth. Its surface shines with brilliant reds and oranges from blooms of salt-loving microorganisms, giving the lake an otherworldly appearance. Yet this beauty hides a chemical reality that is astonishingly hostile. Lake Natron is dominated by sodium carbonate and sodium bicarbonate, chemicals that make the water so alkaline that it can burn human skin, strip organic materials, and preserve dead animals that fall into it. Birds and small animals that land on or near the lake may become encrusted in minerals, leading to the eerie phenomenon where creatures appear calcified, as if turned to stone. But the lake is far from lifeless. It is the breeding ground for millions of flamingos, which thrive on the specialized algae that live in these harsh conditions. The lake's scorching temperatures, often above 40 degrees Celsius, 104 degrees Fahrenheit, and caustic chemistry protect the birds from predators, creating a sanctuary built on danger. Lake Natron illustrates that an acid lake or alkaline lake does not simply destroy life. It transforms ecological niches into highly specialized worlds where only the most adapted species can flourish. The boiling heart of hell, Lake Nyiragongo's lava lake. Not all of Africa's extreme lakes are made of water. Inside the crater of Mount Nyiragongo sits one of the world's largest and most active lava lakes. A churning pool of molten rock that behaves like a fiery counterpart to more traditional acid lakes. While not acidic in the chemical sense, it represents the same geological forces that create Africa's most dangerous waters. The lava lake constantly circulates, fed by magma rising through volcanic conduits. The molten rock can reach temperatures above 1,200 degrees Celsius, 2,200 degrees Fahrenheit, producing gases that escape into the atmosphere and influence the chemistry of nearby lakes, including Lake Kivu. When Nyiragongo erupted in 1977 and again in 2002, lava raced down its slopes with unprecedented speed, destroying towns and displacing hundreds of thousands of people. The relationship between lava lakes and acid lakes is intimate. The gases emitted from Nyiragongo and other volcanoes in the Rift Valley supply the chemical ingredients that create Africa's acidic waters. In a sense, Africa's acid lakes are surface-level expressions of the vast volcanic machinery hidden beneath the continent. The chemistry of life and death, how organisms survive the impossible. Despite their extreme conditions, Africa's acid lakes host some of the most resilient life on Earth. Specialized bacteria thrive in water that would dissolve human skin. Algae live in boiling hot springs fed by acidic groundwater. Flamingos use Lake Natron as a safe haven, taking advantage of conditions too harsh for predators. Microbial mats in places like the Dalal hydrothermal region of Ethiopia demonstrate that life can adapt even to acidic pools with toxic minerals. This resilience has fascinated scientists searching for clues about life on early Earth and the possibility of life on other planets. The chemical extremes of Africa's acid lakes resemble environments that may exist on Mars or on volcanic moons like Io. Studying organisms that survive in these African lakes provides a window into what life might look like in worlds far beyond our own. These lakes show that acidity is not the end of biological possibility. It is a challenge that living systems can adapt to, evolve within, and even rely upon. Human stories and ancient connections. For local communities, Africa's acid lakes are not just scientific phenomena, but part of daily life, tradition, and sometimes threat. Fishermen near Lake Kivu must navigate waters filled with invisible gas dangers. Residents near Lake Nyos remember the night when the lake exhaled death into their valleys. Communities around Lake Natron revere the flamingos and understand the lake's spiritual significance. Colonial explorers once described these lakes with horror, calling them cursed or poisoned. Yet, long before scientific explanations existed, local cultures understood the lake's power. Myths about spirits, warnings, and protective rituals evolved from centuries of observation. These lakes, deadly and beautiful, shape belief systems as much as they shape geology. The human relationship with Africa's acid lakes is a blend of respect, caution, and adaptation, a testament to how people live beside natural forces beyond their control.